right, so what I want to talk about now is I want to talk about three things, and we have time. Okay? I want to talk about mechanical energy. I want to talk about potential energy, and I want to talk about kinetic energy. Okay? This word here is energy. Poorly written. Okay, now, we've already talked about mechanical energy. What does it say here about mechanical energy? Something specific? What does it say? Mechanical energy. All right, section 3 is on mechanical energy.
It's the energy due to the position or to the position of something or the movement of something.
Yeah, it has to do with position or movement. It's very much related to kinetic theory, where you have work is being done by, you have a force that is moving an object, and that object is, as a result of moving, is going a distance. So I'm a gas molecule, I have a mass, I have a velocity, I'm going to have an energy. I can translate that into energy. Remember, momentum is what? Momentum is mass times velocity. So we already have an expression that contains mass and velocity. So the point is, we've measured that. We've done labs where we've measured mass and velocity. Have we or have we not? Okay, so you have velocities measured. So all you have to do is square them now. 1/2 the mass times the velocity squared is a kinetic energy. So if something has a velocity other than 0, what are you going to have? You're going to have movement. As a result of that movement, you're going to have what? It's the D word. It's the D word. You're going to have a displacement. It's going to go a distance. They call it displacement. Yes? That's a displacement. So because we already have an expression for mass and velocity, it's not that big of a stretch to say, okay, well, we can come up with some kind of experimental model that we can measure energies. Because we've already come up with an experimental model where we can measure momentum. So now we've determined the velocity and the mass of something. Now we're simply going to treat them differently mathematically. So the model is basically the same. Some of the math involved is simply a little bit more complex. Mechanical energy, potential energy, and kinetic energy we already saw. They all have the unit labels of what? Joules. Mechanical energy is measured in joules. Enough said about mechanical energy. The energy of motion. Sounds familiar. What is also the energy of motion? When you first learn the theory, isn't kinetic energy the energy of motion? Isn't kinetic energy, in fact, mechanical energy? Because of the displacement as a result of the velocity, isn't it? Potential energy is the one that's a little bit strange. We know that the formula for potential energy is mgh. This is force times distance. This is mgh. This is 1/2 mv squared. But for the potential energy, you're thinking gravity, aren't you? Yes? mgh. You have to think gravity. Because this g is a type of acceleration, isn't it? Acceleration due to gravity. So this equation is for vertical displacement. Do you hear what I just said? Vertical? Define for me, to the best of your ability, the word vertical.
Straight.
Straight. What else?
Y-axis.
Up and down. Perpendicular to the perpendicular to the horizontal. Okay. Parallel with the gravity field. But it's up and down. It's towards the center of the earth. So gravity is going to be involved, isn't it? For the vertical. So if you're talking about G, you must be talking about vertical. Okay? That's potential energy. But there are other, is it off?
No.
Oh. There's other forms of potential energy, and what are they? It's right in the section. They talk about it.
Elastic, chemical, activity.
Okay, they call three of them. They have three of them. Okay? They call it one. What happened?
You just have low battery.
Yeah.
Low battery? Okay, so I gotta stop. They call it elastic. What's elastic potential energy? What is elastic potential energy? It's right in front of you. Come on, guys. What is elastic potential energy? And why are they mentioning elastic potential energy?
Because we already know elastic is.
It says a stretched or compressed spring, for example, has potential for doing work. This type of potential energy is elastic potential energy. When a bow is drawn back, energy is stored in the bow. So a spring, a slingshot, a bow, as in bow and arrows, that's elastic potential energy. What's the word elastic mean in that definition?
Correct.
It's a stretch. What else? But why? But use the word elastic in there. What does the elastic part mean? I take the bow and I stretch it back, and I release it.
Goes back to its original shape.
It goes. There's no deformation. There's no change of structure. It has a memory. It's going back to its original shape. That's elastic potential energy. What about the next one? It says chemical. What's chemical?
Energy position at the submicroscopic level.
Yeah. In other words, if I take wood and I mix it with oxygen, right? What's going to happen is that these they call them reactants. Remember from chemistry? They call them reactants. These reactants. Can I erase some of this stuff? This is really a discussion of potential because we covered really kinetic and mechanical, haven't we? So we're really finishing up potential, and we'll come back to this section too as we progress. Okay, so if I have this equation, I have wood. Well, let's make an actual equation. Let's say CH4 plus O2 yields CO2 plus H2O, right? And we will 2 and 2, and that should be balanced. Is that balanced? Yes. Okay? What happens is this. Here are my reactants. Now, there's other things here. It's a little bit more complicated relative to activation energy and all those sorts of things, but we're going to keep this simple because there's a point to be made. And this is the potential energy. The methane that's sitting in the pipe has potential to do work. And this is very involved. And when we do thermodynamics, we'll look at this in an additional manner. Okay? So those are the reactants and those are the products, right? This is time, and this is energy, enthalpy. We don't want to get too technical here, but because there's a point to this, and the point is simply this, that unstable, stable. And it's always the energy of the products minus the energy of the reactants. It's always products minus reactants, final minus initial. And if I take a small value and I subtract from it a large value, what's the answer going to be, positive or negative? Negative. So negative means it gave off energy. Do you remember what a chemical reaction that gives off energy, what type of... Well, yeah, it's a combustion reaction. Very good, Jeffrey. That's not where I was looking for. But what type of reaction gives off heat? Exothermic. So this is an exothermic. So the heat can be made to do what? It can be made to do work. I can use it. Yes? Okay? Okay? Yeah. And then the energy that's not used is called waste heat. Right? Okay. Let's stop there because the bell's about to ring. Okay? Let's stop. What do we do? 3 videos? Read this. We're going to have a quiz on the early problems. Don't forget. Don't forget. Know it now. On separate paper, those problems have to be done. Clear? And if you have a problem with them, check the website because a lot of them, not necessarily all of them, are done. Okay.